On behalf of Web-based Solutions, I would like to welcome you to our today's webinar, Designing and Implementing Microservices. My name is Mikhail. I will be your instructor and your presenter for today. It's a 1-hour presentation. We are going to touch on a number of topics. So there will be no breaks. If you feel like asking a question, certain things are not clear, send me a chat. That will be your question or your comment. And we will also have a Q&A at the end of the presentation. Okay, so let's get started. So what's in scope? We are going to talk about how to scope microservices. We'll talk about controlling access, whether it's going to be centralized or uncentralized access by your clients to your services. And there will be other topics as well around that generic concept. And then we will talk about other things like maintaining state and designing for failure. Microservices is new, I guess, way to look at something that we have been doing for quite a long time, be it SOA, service-oriented architecture, or maybe your regular applications as well. So what's in scope? Some people equate RESTful web services that have some smarts. They can intelligently interoperate with other RESTful web services, and that's pretty much what microservices are all about. And this is definitely what reminds us of what we did to create SOA services. It's all necessary, but it's not sufficient. There is much more to microservices style of design and more generically microservices architecture type of solutions. So we need to take into account a number of things. It's kind of a more pragmatic SOA. You need to take into account the runtime considerations, operational aspects. The systems are distributed, so how would you manage performance, efficiencies, security, cross-cutting concerns? Definitely, this presentation is not going to be all-inclusive. We would probably touch on some of the points, and we scratch the surface in some areas. But the main idea is to highlight certain points so that you at least are prepared, at least you are thinking along those lines as to how you would create a robust solution based on microservices. So usually, if you're lucky, you can start with a kind of a greenfield project, starting from a clean slate. Everything is just available for you to do the designs the way you want. But in practice, most likely, maybe in 80% of cases, it would be some sort of a brownfield project. It's a project that has been around for some time. It's not legacy. It's definitely requires some facelifting, some kind of infusing new blood into this project. And for that, you need to, I guess, exercise extra care. You have additional constraints, so to speak, when you move on towards the kind of a bright and shiny future of microservices. So what's in scope again? For robust microservices design, you need to think about distributed transactions. So they need to be efficient. In some cases, probably you don't need to pull that kind of a huge, massive amount of data from a server to be processed on the client. Maybe you can do the reverse. You would upload that jar file, launch the service on that server where the data is. It's a principle that Hadoop, for example, uses. And that data physics kind of would work into your favor. You kind of turn the table around. Service scaling in and out. So whenever demand for your service increases, how would you scale? Usually in microservices, this is done horizontally. So you provision new nodes. But that elastic thing, that adjective tells you a little bit more. How fast you can provision those services. Are they going to be hot standby where you would still be paying for these those resources because they're hot? You got a hot spare, but you'll have to pay for that. If it's a cloud or maybe inside your organization, you have some sort of kind of a brown money, if you will, not real money, but it's just between cost centers. So that elasticity is about thinking how would you simplify that virtual machines that you're going to launch. Maybe you will need to move to containers rather than using virtual machines. Data consistency, as long as you go into that distributed world of computing, you need to start thinking about the consistent view of your data. So that Eric Evans' CAP theorem applies in its entirety. Service availability, resiliency to fault. So we're going to talk about that designing for disaster, for faults. It's part of those quality of service that you need to start thinking. We have a monolithic application. That's kind of a all or nothing. And here you can probably have some sort of gray shades of functionality where you would have some reduced functionality not available in full, but at least you would be able to provide a subset of services. Okay, minimizing service disruption when you do upgrades. The more services you have, the more demanding your upgrades. So those rolling out upgrades where you need to make it consistent and to make it such that you don't impact your users by during that maintenance window. So all those things, considerations should be taken into account. So the usual way, what people are using to define the scope is the concept of domain-driven design, called the bounded context. It's a pretty, I guess, kind of a big thing. I guess the author, Eric Evans, I guess he just went out of his way to create that very kind of a academia-like book, but it has lots of value. Essentially, he was trying to bridge the gap between IT folks and business. IT folks, they have different mentalities, they have different vocabulary, and they have different interests, passion about technology. Business is a totally different thing. And in order to bridge that bounded concept was introduced, which would help people to start talking from both sides of the spectrum to talk the same language. Quite naturally, it was called very pompously like ubiquitous language, which essentially is just a language that is very similar to what other people call domain-specific vocabulary-based language, where software folks and business analysts would be talking about the same things. And in implementing your building your solution, you will be using that kind of a vocabulary, which would help you to stay on the same page with business. And usually what you would see is that nouns, verbs, and potential adjectives are transformed into that domain model, which is grouped semantically, which just has that rounded view of the particular problem, and that is the bounded context. So nouns would become entities, services, maybe objects, classes, verbs would be actions, kind of a send, fetch, delete. Adjective would probably add some sort of an aspect of a service, quality of service, like performant, scalable, and the like. So vocabulary is controlled by the bounded context. Essentially, you set up vocabulary which is specific for that domain, and then bounded context is just naturally, organically built around it. You can have definitely, if you have a kind of a not quite straightforward solution, your overall architecture would span multiple subdomains. And the critical thing is not to contaminate one bounded context with the other, so that there is no intersection, no overlapping, so that you don't step on each other's toes and creating redundancies, and which would eventually translate into that maintenance hell where you have to touch on so many parts of your architecture. So you would, again, need to follow with domain-driven design to define that Uber global context, which is called context map, which embraces a number of subdomains. So if you look at the last bullet, essentially context map creates a context where you would have multiple subdomains. That sigma sign is just an indication that we sum up, we add up those subdomains, and every subdomain is mapped into bounded context. It's supported, backed up by a bounded context. So in essence, context map is a bunch of bounded contexts. And bounded context, in turn, there is an I index, which is mapped to a microservice. So that's the chain how you would need to proceed in order to create that context map that would be the foundation, that part of your logical design of your microservice. So internal models and external models, there are things that needs to be kept separate. Internal models is bounded by the bounded context, and the external models that are used as the external service or as a shared service of some sort or model should not overlap with your bounded context. So you just need to establish a contract between that external shared models, other subdomains, and your bounded context, your microservice. That would be a WSDL file, WSDL file. If you use regular web services, if you use RESTful services, use something which is more appropriate, expressed maybe as a JSON document. Okay, so segregate, keep them separate. It will help you to organically grow without complicating things very much. So don't let boundary contexts to bleed into each other. So we're going to talk about this a little bit more as we go. As I said, if you have any questions, let me know. I'm keeping my eye on that chat window. So what are the general organizational principles? So designing is, it's about making choices. You have to trade something for something. And one of the things that you need to look for is favor rapid feedback and change. So rapid feedback and change, it's supported by the sprint, by that kind of agile development practices. So you need to incrementally develop your services. Don't just roll out the kind of a big hello world type of solution. Just start incrementally, do piecemeal rollout, some maybe utility services first, followed by the critical services, and test relentlessly. So reduce inertia so that you have problem and eventually a bunch of problems, and you just have a backlog of problems that you cannot quickly react. So the first and second bullet, they come hand in hand. So also sometimes some people get take a fancy to off-the-shelf products, maybe some existing frameworks. For the most part, yes, like larger frameworks like Spring or maybe something else, they definitely do the job. But if you delegate everything to those ready-to-use components, and your business logic, what you do is not really trivial, then you might have some problem customizing those off-the-shelf products. So maybe your custom-made, your tailor-made product would be a better choice. But it should be balanced off with the do not reinvent the wheel. It has been done for you. It has all the beauties of that design, of something that has been proven to be rock solid in production, so use that. Accidental complexity might come in different shapes and forms. You need to perform, particularly when you do that brownfield design where you already have lots of legacy code. Legacy means that it just has become. You join the company and all of a sudden, just next week, you are responsible for maintaining and kind of advancing an existing application. So, and you need to start applying that principle of what's called Occam's razor, just remove whatever is not necessary for the direct functionality. So how you would do this? You would need to go after some dead code. For that, you would need to do some sort of dynamic program analysis. You run in your testing environment your application, and you test it using some sort of automation tools, Selenium, whatever you have, and you just check which part of your system has never been touched, meaning that it's just an indication that particular code has been probably left as kind of a dead work code, not used anymore. So by just cutting out that code, of course, you have to be very careful so that you don't throw the baby with the water. But it's a good exercise. At least it will show that you are really going in the right direction. Because usually the metrics of a successful developer is how many lines of code she or he has written over a period of time, right? But the reverse is also true. How many lines of code she has deleted during a particular time, like maybe one sprint or one day. Removing code which is not needed, which is obsolete, and just like a dead baggage that you need to carry with you, it's just great. And by the way, it's just a good hallmark of a good developer. Okay, so sometimes what might be happening is that you might not have enough test cases when you do. So it's, again, everything should be taken not just one single bullet as some sort of a prescription. Okay, take this medicine 3 times a day with a meal and that's it, and you'll be healthy. No, it should be just always taken into context so that you have to balance off. There is no proven heuristics how best to do it. And the best heuristics is just common sense and using, trying to balance off things. So back to that thing that we have to avoid, that cross-contamination, kind of a bleeding of boundary contexts into each other. We need to look at things that we have already seen and probably very much familiar. And what I'm saying is object-oriented design. So most of you, if not all of you, have already done this, and probably are familiar with that law of Demeter that states it's kind of a design guideline to develop software so that you don't just know more outside of what you are supposed to know. You just see your input parameters, you have your own logic, and you just produce the output that will be consumed by other classes in your software, in your piece of in your program. And this law can be extended. It can be viewed as a corollary to the principle of least privilege. So that if you don't need this, kind of usually it has to do with security. If you don't need this security right, just you are not granted. So again, those things just help you think in a minimalistic way. So you create that narrow context, narrow service which knows what it's doing and nothing more, right? And everything else, if you want to integrate it into the context of a shared, with shared services with our other subdomains in that context map, then you need to establish protocol, and that protocol should be the only way to interface. There shouldn't be any backdoors. There shouldn't be any kind of ways to plug systems outside that access point. When you go with this microservices, whatever you implement, whether it's maybe some sort of a messaging system based on message broker, or it's a web services, or otherwise some sort of a queuing system, you would probably be dealing, you'll be facing significantly slow performance of your application compared to the monolithic application when everything is done on in the same process image and on the same heap. It will be a matter of microseconds to take data from another RAM bank so that you can process data with separate services running on different hosts. That call that would need to go through across a wire through the network, it would be quite significant. Usually it's like 3, maybe 4 orders of magnitude. Even though now things are getting better because you have Ethernet, gigabit Ethernet with very high throughput, very big bandwidth. Things are getting better, but still you need to be aware that the more services, if you multiply those services, and your communication across boundaries would be quite visible, then things would slow down. So what would be the solution? Try to combine certain microservices and build that monolithic type of a service. Of course, you need to apply all the best practices of software development so that you can kind of evolve the service in organic way. Usually there are some mechanisms like dependency injection, cross-cutting concerns, aspect-oriented programming, where you can achieve all those things without sacrificing the flexibility. So you can organically grow your application, even though it's monolithic. Lots of things, what's happening is lots of things are becoming kind of not politically correct in the IT world to say. Like if you hear someone say like monolithic application, that's just kind of deprecated. It's sort of like a bad word to pronounce, right? Or SOA. No, it's just a matter of how people implement those things. Concepts are great. Implementation, sometimes we cannot deliver on those promises. Okay, so quality of services like security, performance will definitely go through the roof. You will be absolutely happy with those quality of services, properties of your new solution. Cross-cutting concerns, that's something that you have to start thinking right off at the beginning, at the onset. So microservices, they need to be in the context of some system for uniform authentication authorization. You would need some sort of a single sign-on server, kind of a categorized environment. Logging is very important because you need to have some sort of a way to stitch together to get trace all the messages that flow through your system. And for that, you would need to have something similar to like Splunk, Datadog. You would need to have a message correlation ID so that when you make a call, there would be some meta information associated with the call. So it will be part of HTTP request, or it might be part of the meta data, which is associated with the payload. Usually, messaging systems, they provide you that key value pairs where you would set certain things that you can read and if you, for example, make that kind of reply, satisfy the reply needs, like in the asynchronous communications, that correlation ID is very important so that the client would pick up the message that is sent in response to the original request. So log aggregation is important. Logging, definitely, log aggregation, and that system should be some sort of isolated. So if a particular system goes down, you don't have your log system lost. So you need to have a third highly redundant log server, which would be accumulating logs and perform log aggregation for subsequent analysis so that you can apply something for data analytics, the most important calls, latencies, as much information as you can get about the call. So how long does it take, how many hops it had. So there should be some sort of like increment in something like trace RT, right? You make a call and it'll show you how many hops it did, had to go through latencies and probably timestamp and things like that. So auditing is important, particularly if you deal with financial health and this type of sensitive information where you have some sort of auditor or ombudsman of some sort on your shoulder asking you to provide explanation as to why this particular transaction went wrong. State session management is absolutely important. So this is cross-cutting concern. So you need to maintain state across your solution, right? So that is, I would say, that's about consistency, right? And it's important for scalability. We're going to touch on this topic shortly. And don't try to maintain state within your application. It really impacts your scalability. Have some sort of external storage, Redis, maybe Mapcache solutions would give you something that you need, particularly considering that those solutions come with good use cases for things like automatic expiration of your session. That time to leave can be set to say, I don't know, like 30 minutes, so that it will be automatically expired. And those solutions can be used by multiple servers. So essentially, you have that one single source of truth. And whenever a particular service is toast, your session is still survives. Your state sits on that external store, and you can pick it up from there on another machine. Of course, that session needs to be identified by the client, and usually it's done in some sort of a cookie or URL token or something like that, so that you can use that value sent by the client as the key to pick up the value from the cache. So caching generally, as you see, again, it's sort of a segue from state session management into caching. Caching would help you a long way. It just goes a long way. Read through caching, particularly if you start moving your solutions into the cloud, where things all of a sudden become viewed differently. You have to pay for lots of things. You hit a backend system and they'll charge you for that. It will be penny, but multiply that penny by millions of requests per second or whatever TPS you have. Caching is significantly cheaper solution. So if you start thinking along those lines, again, you are prepared. You are good for going to the cloud with very minimum impact on your application. So now we mentioned one of our agenda point was how to access your services. You have, again, to strike a balance between how much you would like to centralize so that you have in control of the data flow, whether you would like to go decentralized. Sort of like peer-to-peer type of communication. Or in case of decentralized client access, so that's what many practitioners believe as being one of the principles. You have kind of multiple services communicating with each other using some sort of a stub. It's sort of a RPC type of thing, and that service mesh pattern does exactly that. You just need to replicate it and install that kind of client library on every service, and it'll jointly would build some sort of a facade interface, so that it will be taking care of maybe authorization, logging concerns, some other cross-cutting concerns. So microservices would be taking over the role for those smarts for versioning, request routing, and format negotiation, convert JSON to XML. And probably it will be great. You will reap some rewards if you go this way, but at a certain point in time, the level of entropy, that chaos, would reach a point where things would not look as good, right? And by the way, what is happening here, if you look at it really carefully, you pretty much have a distributed enterprise service bus, ESB. If you have been for some time in IT, you know that like several years ago, maybe many years ago, ESB was all the rage. Like you got ESB, and that's the solution, that's the backbone for SOA architecture. And what's happening here with those server mesh components, the client use the smarts on every microservice, that every microservice has all of a sudden become smart. Okay, even though some people say it's kind of smarts and dumb pipes, but generally it's a distributed ESB, if you will. And in some cases, probably the old and reliable ESB might help you to achieve certain things and avoid that complexity. So centralized client access gives you that facade service, which essentially becomes a single point of access. You've got two main supporting mechanisms like API management solutions and the facade pattern. It's kind of a gateway service, if you will. There is a chart. It's not shown here. There is a picture that actually shows you. That's a gateway idea. You have just a single point which takes on all the role of the security, logging, throttling of requests to make sure that you don't overload the backend service. Caching solutions can be plugged in here. So again, you kind of become like a single point of contact, and you can do rating, you can do very fine-grained control. If you have a need for backend service maintenance, you can kind of switch off a particular path, that route. Okay, so the facade pattern is also popular as the facade pattern in the Gang of Four book. And you can create that level of decoupling, and that would be your boundary. That would be your kind of frontier guarding your backend services. So how to maintain state? You definitely have to avoid this. Build your application such that they don't have state. So communication is stateless. Push the state out to the client, and do something that just leverage a third-party external caching solution. Don't maintain state inside your application. But state is really great because you can simplify many things. You can maintain that conversational that conversation is between the server and the client using the state, right? So for that, you need to have some sort of a durable store. And for that, again, Redis and other similar solutions is a good choice because you can expire session. You can support scaling, horizontal scaling of your application by just providing access from a newly provisioned server to that caching solution. So how would you maintain? How would that state be kind of revived? How would the client let you know what state it is interested in? Usually, you would use some sort of custom HTTP headers, cookies, part of the request. That will be part of the payload. And then you just extract that value, and that would be the key to the actual value. Many things definitely not a novelty to you, most of you, but I guess it's just I need to go through those things. Micro front ends or micro UI, it's a new concept popularized by many folks who are looking for kind of new ways to essentially new names for all the concepts. But I guess technology really drives and really revives those old ideas and makes them kind of more interesting. So if you remember a while back, portals were like a kind of a mesmerizing term. All the executives, they were talking about portals. We are building a portal, portal to this, portal to that, portal to the other galaxies kind of things. But portals, they had some problems, and essentially those new single page apps that can be created with things like AngularJS, for example, they would allow you to build those data-driven portlets, which can be combined in a suite of services and features, which essentially represent the portal. JavaScript is extremely good now. You can have types safe JavaScript. Browsers are very fast, 64-bit, lots of CPU power. And now your portal essentially is not built on the server. You essentially create that whole UI side, the big kind of portal into your application on the client side. But having macro UI is just a way to now connect that particular applet, not Java applet, just a way to refer to a small app, which is essentially a JavaScript application running in the client, which talks through Ajax or maybe WebSocket to the backend. And that backend has a very close relationship. It's just a backend and front end combined together in one integration pattern. So just visualize it as just some sort of pillars, some sort of verticals where you've got elements of UI elements of the backend joined together, and then those front-end elements. Again, probably a picture would help, but you can go to that link and see how things are done. Essentially, it's just a matter of combining those micro UIs into kind of a bigger UI. And those micro UIs have a link to the backend. Of course, backend can be fragmented. It would have some sort of a shared services. But essentially what you do here, you create that vertical slice which spans your application through the front end, running in the client, in the browser, and your backend. And at this point in time, reactive programming using React, JavaScript, and similar systems, it's a good match. You would be able to create very responsive and user-friendly applications where people wouldn't be stuck waiting for that progress indicator going forever. Okay, so so micro UI, it's just if you adopt this idea and you start thinking how I would incorporate it. It's not hype. It's just a practical thing which is supported by JavaScript libraries where you can start building those single page applications. It helps you to further break up monolithic applications. But now you have to break up your big web UI, where you would have those applets written in JavaScript helping you to address, just have different div sections on your page, and you have those portlets which are very responsive and doing a good job in an asynchronous way. So in this way, you will be able to break up your dev team into smaller teams, working on a particular feature from wall to wall, from front end all the way to the integration with the backend service. Right, it just helps to, I guess, minimize, I guess, unnecessary kind of noise where you have so many people working on just big products. Just breaking it down into smaller pieces would help you organize your work altogether. So your clients are diverse, and now what you also need to start thinking is that you have, in addition to desktop browsers, so you have mobile, and that's where things are moving. So with mobile clients, you have a number of versions. You have native, mobile, hybrid. But the point here is, if you start thinking in terms of MicroUI, you already are on the way to diversify yourself for different clients, because you already have your front end partitioned, and it's easy to expose a particular service without dragging the whole kind of portfolio of your services. You can just expose small thing, and that will help you to gradually build your application. So there is a question, will slides and the replay be available? Yes, we are recording the session as we speak. I also put a link in the chat window. That's a link to the slide deck. It's a PDF file. Actually, I'm going to repeat it. Yes, I put it again. Okay, designing for failure. I guess we're closing in. So this is something that, again, has been around us for quite a long time. We definitely need to start thinking about failure. Failure is just a part of business. It's a norm. It's a new norm, if you will. Anything can fail at the most inconvenient time. So what might help? All those things that we have discussed so far, they already aligned with the principles of that kind of a design for failure. If you don't maintain state on your application, if you externalize it, or you create stateless communication, even better, you're good. Also, you need to avoid provisioning services which, as I mentioned, can consume CPU and will be costing you money if you go to the cloud. And you will need to have a way to apply some sort of auto scaling. And by the way, cloud computing gives you that services like Amazon, Azure, where you just say, I would like to set up a fleet of my servers between, say, 3 and 15. And as demand increases, please provision up to that limit. There would be threshold like CPU, IOs, and response time, whatever threshold you establish. And what happens is that if the demand subsides, if a number of requests are slowing down, going down, then the system would release those resources so that you don't pay for those. Sometimes they're kind of made it as hot standby, meaning that you'll be paying for that, but you can also set it up in a way that services would be essentially the virtual machines, containers would be shut down. In this case, you are not going to pay for unneeded service. So that container-based deployment model is very important. It's kind of a new thing. You might be familiar, know like Docker containers. So it's all about kind of a small, very lightweight virtual machines, which is essentially that Linux feature of Linux containers. It's just a way to share the kernel. It's part of new kernel as of version 2 or something of Linux, where you can launch, essentially you create a clone of your kernel on a much smaller scale, which just exposes a subset of that functionality. And inside that, you can have a stack of configured software stack, which can essentially be viewed as a newly provisioned virtual machine. But it's very high, lightweight. The startup time is just a matter of a sub-second. it does good process isolation, not as good as a virtual machine, but it's good enough. And the density of Dockers on a single machine, if it has enough RAM, is quite amazing. So we have hundreds of those containers running on a single big enough machine with lots of RAM and CPUs, so that they don't starve each other. Essentially, you have kind of a multi-process presentation, so that the kernel will see as if it's just another process running at kind of a zero level, ring level priority. But for the clients, it would be as if there are multiple machines running. Okay, so implementing microservices, there are a number of ways, depending on which school of thought you are adhering to. If you're .NET, Java. For Java, you have lots of things. Currently, there is the concept of this embedded web server, where essentially have that HTTP listener that is exposed to the jar file that you can load into your public static void main application, and that would be essentially a way to instantiate a web server. So you don't have application server, WebLogic, WebSphere, or Tomcat on its own. You do the reverse. You take the jar file and you instantiate it from that main thread. It becomes available. Of course, it wouldn't have JSP compiler, JSPX compiler. It would be just a matter of exposing RESTful endpoints. Okay, and here's a list of some of the popular frameworks. Again, it's for Java. I'm pretty sure .NET does the same thing. So Spring Boot, .Visit, Spark. Node.js is a very popular one. Sometimes, I guess, it becomes a little bit kind of too verbose with those callbacks. And in some cases, if you just compare what you can do, just compare a Node.js application with something that you can create with Spark. Don't confuse it with Apache Spark, which is a cluster, massive parallel processing thing. Spark is just a Java Spark thing, and it does the same thing, but it's much cleaner, and it's type safe. With Node.js, you would probably be not as safe, but Node.js gives you other benefits. Okay, so we offer a class for these topics. So if you are interested, click on that register now, review the outline. So that's it I've got for today. We've got about 10 minutes for Q&A. Are there any questions?